morning, students. How are you today? How are you on this fine Saturday morning? For me, it's Saturday morning because I'm drinking my burger coffee. Oh, I still haven't made a dime from burgers. I keep doing advertisements, but they're not sending me any revenues. But I'm still enjoying the coffee, kids. All right, today we're going to be discussing how to graph the tangent curve. Oh, that looks cool. The secant curve. The cosecant curve. My goodness, you know what I forgot? The cotangent curve. Cotangent curve as well. So we'll be doing a little bit of that. It's not too difficult. A little strange. A little odd. But so are you. So am I. So are we. We are a team. We're going to kick this Algebra 2 exam at the end of the year's butt. Alright, look. Let's talk about radians. Let's talk about radians. Let's talk about them. Oh man, I'm a sick singer and I can't even stop clicking on things. I don't know. You know me, my pen doesn't wake up. You know, I think my pen should drink some coffee because it often has times having a hard time waking up. Let's see how well I write for a little while before my pen wakes up. Hello. Okay, so what am I talking about? Radians. When you get your calculator on the Radians exam, hopefully your teacher has done you a service, your school has done you a service, provide you a little coffee. By the way, if you want a countdown counter to when your exam is, just go to mrkrausmath.com, and then all these videos will be in order of what you need. Just go to one of my classes, and you'll find Unit 8. Oh no, we're in Unit 10. 10. Oh my God, it's 10. We're getting close to the end. And you can watch them all in order. But anyway, I don't know what I was talking about. Oh, there's a countdown counter there for the Radians exam. So, want to see how long you have until the Radians exam? I think it's, let me check. Let me see, I haven't seen it in a while. Alright. Let's see. mrkrausmath.com. There it is. Oh, man, there's that ugly mug of mine. 76 days, 2 hours, and exactly 4 minutes. Well, now it's not 4 minutes, but anyway, you get the point. Coming back. Alright, so, radians. We're going to use, we only really want to use radians, so make sure your teachers have their, that's where I was going. A little tangent. I'm going to be off on tangents today. You really only want to use your when you're doing two different things. One is when you're graphing the tangent, forgot the end, cotangent, cosecant, secant, or the sine inverse, cosine inverse, or tan inverse functions. Pretty much won't do anything else. So you don't really want to be in radian modes unless you're graphing these particular functions. We'll also be in radian modes when we're doing some sine regression. When we're doing a little bit of trigonometric regression. Other than that, you really want to make sure that you are always in degree mode. And you want to make sure your calculator is in degree mode. The easiest way to do that is, that's not your calculator, is to take it and hover over this. Oh, gotta be in like a mode. Let's go into graph mode for fun. And you hover over this. Oh, I'm in radian mode. Why am I in radian mode? Let me get out of that. That's crazy. Let me go to my home. I gotta make sure that I am not. You always want to make sure. See, I'm in degree mode. I don't know why. I don't know why it said I'm in. I'm gonna make that the default. Now, when I go back into graph mode, I don't know why I'm in radian modes. But anyway, we'll talk about that in a few minutes. No big deal. But you want to make sure that when you're working with your calculator, you're in degree mode. I think if I go into calculator and then I'm in calculator, yeah, see, I'm in degree mode when I'm in calculator. So I don't know. We'll see. At any rate, kids, coffee. Let's get started on some math. So the first thing I want to do is I want to create a new document. Now, the reason I want to create a new document as opposed to just start working on it, because I am, there we go. I don't know why that's working like that. Okay, this is going to be a freaky day. And it didn't even work. So let's go back into, am I going to be able to draw? Good. So let's go. Let's get started. Oh my God. What is going on with my computer? Okay, I can do 100%. Maybe it doesn't like it when I go too big. Alright, that's going to drive me crazy without that being big like that. So let's go to 150%. Let's go to 125%. Alright, so anyway, so what we want to do is we want to create a new document on our calculator. Ah, there we go. So we'll go into, let's see, this is calculator. Let's go to the home screen, and we'll hit doc. And we'll do new document. Oh, I never want to save anybody else's crap. Assume the person before you was like Gomer, or like the dumbest kid you know that doesn't even know how to turn on a calculator, because you want to make sure you're not using their crap. So just click no, and we're going to go in and create a new graph. And then what we're going to do is we are going to go, well, what I want to do right now is change the Windows settings. So I'm going to go into doc, and you'll see in here I can change the settings or status. And I want to change the document settings, because it only will change the settings on this document. And we'll click on Radians, and we'll click OK. Notice I'm going to click OK, not make default. Okay? What that will do is it will change it just for what we're working on right now. So we're in Radian mode, which is kind of cool. That's what I want to be in. I think I can make this larger. Let's go to zoom 200%. Ah, okay. So that's fine. And then I want to graph the tangent curve. Now what you're going to watch, or what you're going to see, is some obnoxiousness. Tangent X, and I'll hit enter. And it's kind of crazy. This is what the tangent curve looks like. It's a squiggle. It's a squiggle. But right now it's graphed from -10 to 10. I have no idea. This is 1. That's 2, but that's kind of useless. And I really don't get a good sense of what's going on with this curve. So what I want to do is I want to change the way this looks. So we're going to go into menu, and we're going to go into zoom, and we're going to go into the Windows settings. And I want to change this so that the numbers actually make sense. So from left to right, I'm going to change it from -2 pi to 2 pi. Because that's how we normally graph anyway. So might as well graph from -2 pi to 2 pi. And I'm going to change this settings, not to auto. I'm going to change it. I want it to be pi over 4. Pi over 2. Now we'll go pi over 4. Pi divided by 4. At least I get a sense of what's going on. I know what the tick marks mean. It's not 1, 2, 3, 4, 5. I know what they mean. And I don't really think this matters. I think on your sheet you have, what, -5 to 5. So we'll just stay with that. -5 and 5. We'll let auto pick on that one. That's no big deal. The vertical doesn't really matter. You're going to find out it's really the horizontal that matters. So let's click on this. So now I think I get a sense of what's going on here. If you look at this graph right here, this is pi, well, let's go this way. This is pi over 4, and this is pi over 2. We're going to talk about that pi over 2 in a few minutes, because that's going to become real important with the tangent curve. And then we'll go over here. This is right here. This is pi. Notice it's at pi, tangent 0. We're going to talk about that. And then when I go over to here, this is 3 pi over 2 and 4. Now you'll notice from left to right, the tangent curve increasing. It's increasing. It's going up from left to right. That's going to become important, because that's what cotangent does. Now, you'll notice that it looks like it's going down, and then it gets really, really steep. And it doesn't look like it's going to cross this point right here. Or it doesn't look like it's going to cross this point going up or going down. What do we call those? Yeah, I know. It makes you feel like you're going to swear. We call them asymptotes. So, here we go again. Not going to work again. All right, we'll call them asymptotes. And we got asymptotes everywhere on this graph. And let me just tell you where they are for the we're just going to work on this interval from negative 2 pi to 2 pi. So those asymptotes are at negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. Now the domain, if we go back and look at the graph, the domain, it looks like it's all reals coming from left to right, except that it can't cross these asymptotes. And again, we're going to talk about that in a few minutes, why that's true. So the domain is really x is in the set of all reals, except that x cannot equal plus or minus pi over 2 or plus or minus 3 pi over 2. And that's if we're just talking about the range from, again, negative 2 pi over 2 pi. If you were to describe the range or the domain, if you were to describe the domain of the tangent curve, you'd have to say every multiple of pi over 2 does not work. Every time we get to a multiple, no, not every odd multiple of pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, all of the odd multiples of pi over 2. It's kind of weird. Let me get back to our color. And then a range then, I mean, it clearly should be obvious that the range goes up and down forever, so the range is all reals. So you could either do it like this, x is in the set of all reals, or you could do negative infinity to positive infinity, or you can do negative infinity is less than y is less than positive infinity, whatever. Those are your range. All right, let's move on. Next page. Oh, we're going to actually graph this thing. Well, okay. So the first thing I want to do before I graph this thing, and it says it right there, is I want to graph my asymptotes first. So anybody else feel like they got a dirty mouth, clean it up with Burger's coffee? Now these were vertical asymptotes. So we're going to draw those vertical asymptotes in. I am not good at drawing on this. So there. And there. And at pi over 2. And at 3 pi over 2. So all the odd multiples of pi over 2 are undefined, or asymptotes for the cosine curve, or the tangent curve, excuse you. And let's go back. How about we graph in black? We'll go in black. We'll go thick black. Okay, so thick black. So now, in between each of those, let's go back to the graph. Notice in between each of those, so here's 3 pi over, well, let's go over this one. Here's negative pi over 2, and here's positive pi over 2. What did you notice in the middle? 0. From negative 3 pi over 2 to negative pi over 2, in the middle is a 0. So that's how we're going to graph these. The middle is a 0, and that will make sense in a few minutes on why that's true when we talk about this. So in between each one of these is a 0. And we've already talked about that from left to right. From left to right. What was I going to say? From left to right, they are... Oh, increasing. I should probably go back. From left, so I see from left to right, notice it's going up. Got a little squiggle. By the way, if you draw a straight line, I'll wreck you. I will. Now the other thing I want you to know is, and again we'll talk about this at pi over 4. So this is pi over 2. This would be pi over 4. At pi over 4, it's really 1, and we will talk about that later. Now notice when I draw this, or negative 1, when I draw this, I don't cross my asymptotes. If you cross your asymptotes, I'm going to kick you in the asymptote, if you know what I mean. I didn't swear. I said asymptote. So we have a new curse word for glass. Anytime someone's misbehaving, we could tell them shut up, or we're going to kick them in the fractioning asymptote. That doesn't really sound good. So Mom and Dad, I didn't really say that. But we are having fun with math, and having fun with math is most important. Notice I'm drawing, oh my gosh, my drawing are redunculously awesome. I know that's what you're thinking. You're probably thinking, oh my God, I wish I could draw as good as Mr. Krause. He's like freaking Picasso. So from left to right, notice they're increasing. And there is the tangent curve. All right, let's talk about this tangent curve. Let's talk about a few things. I think that you probably remember that tangent. What is that tangent identity equal to? Come on, spit it out while I drink some coffee. Thanks, Dad, for doing this, by the way. I really appreciate it. You're in my 4-set class. So let's see. Who am I going to mess with in my 4-set class? I don't know. Sine of theta over cosine of theta. I got my twin bro in the back. Hey, twin bro. Don't you dare put hair on me again. Made me look like a daggone chia pet. Sine over cosine. Now, wait a second. If you're talking about these points, aren't the points, as we want to think about them, cosine x and sine x? So let's see what happens at 90 degrees. 90 degrees is right here. At 90 degrees, this would be 1 over 0. Well, isn't that undefined? And at negative 90, coming back 90 degrees, that would be negative 1 over 0. Well, isn't that undefined? Now, the 270s, if I go either positive 270 or negative 270, that still gives me either, in this case, negative 1 over 0, which is undefined, or positive 1 over 0, which is undefined. This is why, when we look at the graph, we look back at the graph here, by the way, you do know this is 270 degrees, right? And this is 90 degrees. This is actually negative 270 degrees. This is negative 90 degrees. This is positive 90 degrees. And at this would, this is positive 270 degrees. At each one of those, it's undefined. It gets really, 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 really close. Now, why is that? So watch what's happened. Let me get as x gets close, or as the angle gets closer to, let's say, 90 degrees, my x value is getting closer and closer and closer to 0. So my sine value is getting closer to 1, and my denominator is getting very, 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 very tiny. Very tiny. But it never, eventually it gets to 0. So that's why you can't ever hit this asymptote, because you can't have 1 over 0. So at pi over 2, it's 1 over 0, or negative 1 over 0, or negative 1 over 0. You're going to have an undefined. So a tangent curve is always undefined, wherever cosine of theta equals 0. And that's at 90 to 70, and you can just keep going and going and going, every odd one. All right? So that's the tangent curve. Pretty simple. Let's talk about the cosecant curve. All right, so the cosecant curve. We're going to graph this on our calculator over negative 2 pi. So let's take out the calculator. Let's see what we got. I don't want to change my settings, so I'm just going to hit the tab button and then hit the up arrow. We're just going to change this. So we're going to delete this. Oops, I don't want to delete that. Let's hit here. Delete. So I hit the tab button, hit delete, hit the up arrow, and then we're going to go to graph cosecant of x. Now this one's going to look seriously funky. Woo! Sweet! Nice. By the way, why is it 6.28? That would be 2 pi. So if you'll notice, it looks like we got asymptotes like everywhere. It looks like there's another asymptote here, and another asymptote at the origin, or at the y-axis, and another asymptote over here. So let's think about this curve. Oh, well, isn't every one of these pi over 4? So that's pi over 4, that's pi over 2, 3 pi over 4, and this would be pi. And this would be negative pi. And then we have one at 2 pi, and we have one at the origin. So we're going to go draw our asymptotes in. And I'll try to use a large red. So our asymptotes are at the y-axis, negative pi, and negative 2 pi. pi. And positive 2 pi. All right, so isn't cosecant x just the 1 over sine of x? Yes, it is. And what is the sine of 90 degrees, which is really pi over 2? Would you agree that's 1? So this would be 1 over 1 at 90 degrees. Right there. So cosine and sine at 90 degrees will be the same. Well, if we go back to the graph then, wouldn't it make sense then, if this is 1, wouldn't this be negative 1? And this would be negative 1? And this would be positive 1? Yep, it would. So the key point is, and you don't have to memorize this, you just have to be able to recognize it. And I'm going to show you a quick way to recognize it, is that the secant curve, I like to say the secant curve, which we'll draw our asymptotes in. Remember, don't cross. Our secant curve, our cosecant curve, which is the co-function of sine. Remember, math teachers didn't like you, so we switched those letters around on you. Cosecant curve, which is the co-function of sine, it rides on the backs of the sine curve. It just rides on the backs of the sine curve. So if I were to draw the sine curve in, wouldn't the sine curve look like this? And then come back to a 0, and then go back to the bottom, and then go back to the 0. And I can go back and forth in each direction. Boom. In the middle, I'll go to a 0. And this goes to a 0, and this goes to 0. So if you'll notice, the cosecant curve rides on the bellies, or on the humps of the sine curve. And that's the easiest way to remember it. Why are these lines of asymptotes? Why are these asymptotes? Well, those are where sine is equal to 0. And isn't sine equal to 0 at any pi's? At the pi's and 2 pi, and 0 at 0 and 90 and 360, that's when pi is equal to, or sine is equal to 0. Well then, cosecant shouldn't be a problem. I should really understand then what cosecant looks like. So let's hit the tab button, hit the up arrow, let's delete this, and let's try secant of. Now it shouldn't be any surprise what secant's going to do. Clearly, secant will ride on the humps of the cosine curve, and that's what we're going to want to do. So well, notice that we still have lines of asymptotes for the cosecant curve. What are our lines of asymptotes? Well, they're where cosine equals 0. Well, that's the same as when tangent was equal to, where tangent lines. So those are all the odd pi's over 2's. So at all the odd pi's over 2's, we're going to have asymptotes. So once again, let me get my red pen, at this 3 pi over 2, because remember, secant theta is equal to 1 over cosine theta. Well, where is cosine theta equal to 0? That's at 90, 270, and then at negative 90 or negative 270. So at all of those, which is what I'm doing, this is negative 270 or negative 3 pi over 2, and this is negative pi over 2, and this is positive pi over 2, which I just drew amazingly awful. And this is positive 3 pi over 2. I'm sorry I'm not looking you in the eye. I'm really dreaming about drinking some more coffee. And, again, when does cosine theta equal 1? Cosine theta equals 1 at 0 degrees and at 2 pi. It also equals negative 1 at pi, or 180 degrees. So at 0, it's 1, and we know at 2, and over here, it's a maximum. That means in between, it is a minimum of 1. And the cosecant curve, let me change colors, the cosecant curve rides on the bellies or on the backs of the cosine curve. And don't cross the asymptotes. And over here, it would ride up. And let's see, this one, at pi, it's negative 1, and we'll go down. And at 2 pi, it's positive, or negative 2 pi, it's positive 1, and we're going up. So again, if you want to, draw in the cosine curve. Doesn't the cosine curve start here, come down? Isn't this what we draw when we take a look at the cosine curve? Yeah. So the secant curve, which is the co-function of cosine, just rides on the back of the cosine curve. All right, moving down. Let's try tangent. Now, if you know anything, you know that tangent of theta is equal to cosine theta over sine theta. We're going to memorize this a lot over the next few days. Well, then shouldn't it make sense that this will be undefined or have asymptotes when sine theta is equal to 0, because that would make this fraction undefined. Well, sine theta equals 0 at anywhere cosine equals 1. So 0 and 180 and 2 pi. I'm mixing things up. 360. If you want to do it in radians, it's pi and 2 pi, or negative pi and negative 2 pi. And clearly, if we come over here and take a look, hit the tab button, hit the up arrow. The reason I'm doing this, by the way, is I just don't want to have to reset my document settings and go back, change everything to radians. I'm just going to keep using the same graph. So go in here and we'll graph. I told you we're going to graph cotangent. It should come as no surprise, I think, what the cotangent curve looks like. It's going to look a lot like the sine curve. It's actually going to look a lot like the tangent curve. But instead of going up, it goes down. So this cofunction comes down. Notice where are its lines of asymptote. I said it was going to be at 0 and at pi and at 2 pi, or negative pi and negative 2 pi. So let's draw anytime you're going to graph these, draw your asymptotes in first. Otherwise, you're going to be an asymptote. Oh yeah, I said it. It was the coolest, sickest joke ever. That's because I'm not only a math teacher, but I'm a comedian. So anywhere cosine will be 1 or sine will be 0, that's the most important part actually, is when this will be undefined. Because you cannot have 0 in the denominator of a function of a fraction. And then again, just like the cosine curve, in between, or just like the tangent curve, in between, I don't know, I thought I switched colors. In between are all zeros. The thing you have to remember is tangent goes up while cotangent squiggles down. And don't draw a straight line, and don't forget your arrows. Remember, it goes on forever and ever and ever and ever and ever and ever and ever and ever. Alright, so you guys got it? Got lines of asymptotes wherever sine is equal to 0. Now, you don't have to really memorize these or really be able to just reproduce. You need to recognize them. So I finished cotangent. Let's quick talk again. If I need to, I can skip this section if you're running out of time in class. Let's quickly talk about tangent again. I want to make sure you have a real good, solid foundation of tangent. Remember, tangent is equal to sine over cosine. It will have its undefined points when cosine is equal to 0. Cosine is equal to 0 at the pi over 2s, all the odd pi over 2s. So 1 pi over 2 and 3 pi over 2. 90 and 270. 90 and 270. In between each of those will be a 0, because that's where sine is equal to 0. Sine is equal to 0 here, 0 over 1, 0 over 1, 0 over 1. Actually, some of them are 0 over negative 1s, but I'm not going to worry about that. And then tangent is increasing from left to right. Don't cross your asymptotes, you big asymptote. Just kidding. Love you guys. Really, I'm not looking forward to summer break at all. Just be careful of that last one. Okay, there's the tangent curve. What is the range? We've already talked about this. There is no restriction on the range. It goes from positive infinity to negative infinity. I'll do it in interval notation. It's the quickest. The domain. Well, the domain is x is in the set of all reals. I like to write it like this. X is in the set of all reals, but x cannot equal plus or minus pi over 2 or plus or minus 3 pi over 2. Remember this. I'm going over it again just in case you missed it. And the asymptotes. Now, if you remember correctly, vertical lines are x equal lines. And that's when x equals plus or minus pi over 2 and x equals plus or minus 3 pi over 2. All right. Man, I'm already 30 minutes in. Okay, so is this a function? Sure, it's a function. It passes the vertical line test. Yes. Is this a one-to-one function? No, it fails the vertical line test. Is this a inverse function? No, because it has to pass the horizontal. Excuse me, it does not, because it doesn't pass the horizontal line test. And in order for it to be a function, it has to pass the horizontal and vertical line test. Well, is there a way we can restrict our domain to make this a function? And I would argue if you get rid of all of this, does it pass the vertical and the horizontal? Don't worry about the asymptotes. Does the black curve now pass the vertical and horizontal asymptotes? And yes, it does. So if we restrict the domain, and we restrict it from, now remember it's parentheses because you can't equal pi over 2, negative pi over 2, comma to pi over 2, then yes, it would be a function. You should be able to answer all of these. You should be able to answer all of these here. Well, how long are we in? We have 30 minutes? Oh, we got plenty of time. Okay, so if I go back to my graph, I wish I could go. I wonder if I can undo. Undo. I'm going to undo my graph so I can go back and look at it. Ooh, I don't know what just happened. I thought I was hitting undo. Oh, no. There's my graph. Okay, I'm back. Okay. So there's my graph. So I want to take a look at it, and I want to ask the questions. What is the value of tangent of 90 degrees? All right, so the tangent of 90 degrees is right here. That's 90 degrees, and my value is, because it's an asymptote, it's undefined. And while I'm up here, 3 pi over 2. 3 pi over 2. Again, an asymptote. It's undefined. At 180 degrees and 0 degrees. All right, let's look. 180 degrees is the same as pi. That's 0. 90 degrees. No, was it 90? Oh, 0. And 0 degrees. That's right here at the origin. They're both zeros because that's where tangent is equal to 0. And remember, at 2 pi, that's the same as 0. That's undefined. And then pi over 2, again, is 90 degrees, and we know at 90 degrees it's undefined. Before I go into this next section, I want to take a look at sketching very quickly what the inverses of these look like. If you remember correctly, the inverses are just reflections over the line y equals x. And I've had issues graphing inverses on this before, but let's see if we can do this. Hit the tab button. We'll go up here. We're going to delete this. And we're going to try to graph cosine. Now, in order for it to graph, we have to graph it in a certain period. Now, if you remember correctly, now we'll do sine first. We'll do sine inverse of x. Ah, there it is. Now, if you remember correctly, we are going to switch the x and y in order for it to be the inverse. Now, is this 0, 0? That was on the original sine curve, 0, 0. And that's why this is still a point on the inverse. And this point over here is pi over 2, it's hard to see, pi over 2, 1. Or in this case, when we reversed it, it became 1, and then this is pi over 2. That's why this is at 1 right here. See, this is at 1 and pi over 2. So this is the sine curve. The key is with this one is it's going to have the point at the origin. And you should be able to just recognize it. Oh, yeah, that's the one. You know, that's the one that's going to go because, oh, I wish I could draw it. So, I wish I could draw on this. I can't. If you were to think about the sine curve, wouldn't the sine curve go like this and down? So this point up here would go over to that point over there. Yeah. So anyway, or if you graph the line y equals x, this point, the big thing is this origin point. Because watch what happens when I graph the tangent or the cosine curve. Let's get the cosine inverse in there. Oops, that should be equals. Go back to equals. Trig cosine inverse. Now, cosine inverse. Notice here wasn't the original point for cosine inverse up here, 1, 0. Well, when I switch them, it becomes 0, 1. And it was pi over 2, 0, and so now the pi over 2 is up here. And so the one thing you're going to notice about the cosine inverse is that the point where it crosses the y-axis is up here. Not at the origin, because the sine curve is the origin, because the original sine curve has 0, 0. When I switch x and y, it's still 0, 0. But the cosine curve does not. It goes from pi over 2, 1 to 1, pi over 2. So anyway, that's the cosine curve. Be able to just recognize that that's the inverse cosine curve. And let's try one more. Let's try the tangent. And let's delete all this. Tangent inverse. Tangent inverse is kind of easy to recognize. Because I'm going to ask you to do this tonight. Just real quick, can you recognize them? Tangent inverse. And tangent inverse is basically just, the tangent curve went like this. So it's just reflecting. It's a reflection over the line y equals x. The tangent inverse one's actually pretty easy to do. Alright, so let's go back. Again, you're not supposed to have memorized all that stuff. You're just kind of supposed to hopefully be able to figure it out. Okay. And here I am again. Let's go here. That's tomorrow's stuff. Go back. Okay. So, I also expect that you will have these memorized. I expect that you will have these memorized. Okay, so I want you to memorize that the tangent of 150 degrees. Well, let's talk about first the tangent of 30 degrees and the tangent of 60 degrees, because these are the two I expect you to have memorized and locked down, because they'll give you tangent of 150 because it's the same reference angle. So what isn't tangent of 30 really the sine of 30 over the cosine of 30? And isn't this really equal to, let's see, the 1/2 over the radical 3 over 2? Now if I flipped and multiplied, the halves would cancel. So what I really end up with is 1 over radical 3. And when I rationalize that, you all know by now that's equal to radical 3 over 3. So tangent is radical 3 over 3. And that's how I actually remember it. I remember that, oh yeah, it's the small one, 1/2 on top, the square root of 3 over 2 on the bottom, 1 over radical 3. That's this one. And then tangent of 60 is the sine of 60 over the cosine of 60. Now this one's easy to remember, so if you'd rather remember this one, remember this one. This is when sine is equal to square root of 3 over 2, and cosine is 1/2. Well, again, the 1/2's cancel, and I end up with the square root of 3 over 1, or just the square root of 3. So these are the main two you need to memorize, but they're going to help you memorize these. Now, oh wait a second, tangent, all students take calculus, tangent's positive in 1 and 3. So in the second quadrant, it's negative. It's got a reference angle of 30, negative square root of 3 over 3. We're in the fourth quadrant. Wait a second. Let's go. The 45s are the best. So the tangent of 45 is the sine of 45 over the cosine of 45. Well, aren't these the square root of 2 over 2 over the square root of 2 over 2, which is just 1? So anytime you have a 45 with tangent, it's going to be equal to 1. Well, this has a reference angle of 45 degrees, but it's in the fourth quadrant, so it's negative 1. This has a reference angle of 60 degrees, negative square root of 3. This one has a reference angle of 45. It's in the third quadrant, so it's just positive 1. This one has a reference angle of 60 degrees. It's in the third quadrant, so it's positive radical 3. Oh, and this one's also in the third over here, quadrant. Man, could not come up with that. So it's positive, but it's positive radical 3 over 3. Get them memorized, kids. You got to have them memorized. Lock it down. All right, so let's talk. Is this the last thing I want to do? I think I just want to graph this, maybe 2 graphs. We're going to graph 2 graphs And then I'll get you out of here. If we don't have time for the last one, that's okay. Okay, so how long are we in? We're in 40 minutes now? All right, good. So, wow, that's weird looking. It's going to become okay. I want to graph this for one full cycle of the sine curve. And so I just decided to throw these in here just to kind of give you another look at something and have you practice with these. So we're going to get A equals 6. Don't sweat this out. We're going to do this right now. B is equal to pi over 6. And then we're going to go right into period. The period is equal to 2 pi over 6. And I really want you to get good at doing this. When you divide by a fraction, you really flip and multiply by the reciprocal. You're going to multiply by the reciprocal. So we get 2 pi over 1 times 6 over pi. Well, the pi's cancel, and I'm left with a period of 12. 12? Don't sweat it out. Drink some this. I completely missed my mouth. Yeah. Back to class. Okay. I don't know where pen is. Don't sweat it out because, hey, I don't have to count by pies anymore. I can just count by numbers. Because now my x scale, which is going to be done the exact same way for these, my x scale is 12 over 4. It's still divided by 4, so every 3 tick marks. I don't have a C, it's just 0. My D is -2, so that makes my midline y equals -2. I have a min of -2 minus 6, or -8. And I have a max of -2 plus 6, which is 4. So I want you to draw one full cycle of it. So I'm not going to put my x-axis in the middle, or my y-axis in the middle. I'm going to do it way over here. And I can put this in the middle. I'm going to slightly bring it up to the top, only because I know I have to go further negative than positive. So there's my x-axis. There's my y-axis. Some sick drawings there, I know. Alright, so let me put it in my midline. My midline is y equals, what did we say that was? Y equals -2. Dotted line. I'm going to put my scale in, and it says every 3. 1, 2, 3, 4. That's 12. And that's 3. Now, let's get the max in there. 1, 2, 3, 4 is my max. And 1, 2, 3, 4, 5, 6, 7, 8. Hope your drawing looks better than mine. -8 is my min. Alright, so we're going to start. The sine curve always starts at a minimum. It will end at a minimum. In the middle, it will be a 0. It starts at a 0, ends at a 0, and in the middle it will be a 0. In between, it will go up to its max. In between over here, will go to its min. And we are done. One complete full cycle of the trig curve. All right, let's do the last one. All right, cosine. Let's do it. A equals 5. B equals pi over 3. Sounds troublesome. Period equals 2 pi over 3. 2 pi over 1. Flip and multiply times 3 over pi. Go back to red. Pi, I didn't go to red. Pi's cancel. I end up with 6. So my period is 6. Oh my gosh! I thought I switched this. This is supposed to be a 4. This will be switched on yours. This is supposed to be a 4. So on yours will be a 4. So 4 and 4 and 8. And you'll see why now. X scale equals 8 over 4, which is 2. So now I'm going to put a tick mark every 2. I don't have a C. My D is 3, or Y equals 3. My min is 3 minus 5 or negative 2. My max is 3 plus 5 or 8. And I'm ready to graph. Let me grab red and let's see how good I can go down this thing again. I'm actually hitting the line this time. Oh man, see, I spoke too soon. There's my y-axis. And it doesn't matter where I put my x-axis. I don't have to go up too high or low. That is really difficult to do. If I could do it on my screen, I don't know, maybe that'd be easier, but not that easy. X, and Y. Let me draw the midline in. My midline is 3. Let's see. That's the origin, right? 1, 2, 3. Boom, 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 boom. I gotta get up to 8. 4, 5, 6, 7, 8. Got lucky there. That was kind of dumb. And I gotta get down to negative 2. There's negative 2. Alright, so... Oh, we need the Y scale. 2, 4, 6, 8. Good enough. Now, let me grab it. Let's graph in black. A cosine curve starts at its maximum and it ends at its maximum. In between, it's at a minimum. In between those are the zeros. There it is. And my kids, that's it for day 1. Graphing the weird functions and graphing a couple of strange functions at the end there. Alright, your homework's not going to take you that long. Good luck. Persevere. Work hard. Achieve success. Hit subscribe. Adios, amigos. Have fun storming the castle. I don't know why I say that all the time. Bye.